So in this example, we want to look at the region that's bounded above by the x-axis, by the line x equals 0, by the line y equals x, and by the line 5 minus x. This is y is equal to 5 minus x. This region that gets revolved around the y-axis. So one thing we need to figure out is where do these two meet? So where is it that y is equal to x and y is equal to 5 minus x? Where do they meet? They meet when x is equal to 5 minus x, or 2x's is equal to 5, or x is equal to 5 halves. So this is the point, 5 halves, comma, 5 halves. Now, if we are revolving around the y-axis, we can actually split this region into two. So, for example, this point here, the radius is defined by this function y is equal to x. So we could form the integral that goes from 0 to 5 halves, these are y values, of pi times the radius squared. Now, the radius we want to write in terms of y, and we'll integrate with respect to y. So y is equal to x, our function then is just y squared. Then plus, above that, the radius would be defined now by this line 5 minus x. So if y is equal to 5 minus x, we can write this in terms of y's. Well, x will be equal to 5 minus y. So we could write the integral now as y goes from 5 halves up to 5, because remember, this is the line 5 minus x, so its y-intercept is 0 comma 5. So as y goes from 5 halves up to 5, pi times the radius squared, written in terms of y, the radius is 5 minus y squared, and we'll integrate that with respect to y. Okay, so this is some just basic polynomials once we have it set up. This will be pi times y cubed divided by 3. We evaluate that one from 0 to 5 halves. Plus pi times, now you'll expand this, and when you get done integrating, remember 5 minus y squared is 25 minus 10y plus y squared. So once you integrate, we'll get 25y minus 5y squared plus y cubed over 3. And you need to evaluate that from 5 halves to 5. This one's quite simple. This will be pi over 3 times just 5 halves cubed. So in the end, what you'll get is 125 pi over 24. Now on the red part, you go through the integration dot, 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 dot. You will also get 125 pi over 24 there. And that makes sense because our region here is symmetric. Okay? But in the end, then you just do a simple calculation. This becomes 250 pi over 24, which after reducing is 125 pi over 12.